Hey, welcome back to the Algebra 2 series. Today we're working on some trigonometry, and this comes from our Chapter 7 material. And what we're trying to do here is verify whether an equation is true or false. Well, of course, we're not using a calculator here. It would be pretty straight up to use a calculator. But we're trying to do this by hand to see what types of relationships come about here. So notice that we've got the sine of 40, cosecant of 140, tangent of 230, and the cosine of 140. Let's get started with this right away. The first thing I would probably do is I would notice that the sine of 40 is the easiest of the angles, and I have already drawn a triangle here in quadrant 1. I'm going to mark the corner angle there in standard position with a single mark indicating that it's 40 degrees. And then I'm going to make up some letters to represent the different sides of that triangle. I'll write in an A here, I'll put in a B there, and a C over here. Next, I'd like to do that with the other angles as well. So we go over to the second one, and I'll change colors just so that it's a little clearer. We'll go to the cosecant now. I'm going to change that red to orange. There we go. And this is at 140 degrees. So that would be over here in quadrant 2. And let's see if I can get that to be about the same pitch as the other one. That looks pretty good. And then I'm going to drop down another altitude here. And notice that the angle down here, the reference angle, is indeed the same. It's 40 degrees. But the numbers that we put in are not quite the same. There would be a C here, but this should be a negative B if that is a positive B in quadrant 1. And the A value stays the same. So notice we'll be using that triangle for not only the cosecant, but for this cosine as well. So that helps us out. We only have 3 triangles to draw. Finally, let's do the tangent of 230. So this time we'll go down into quadrant 3, and we'll notice that in quadrant 3, this is not a reference of 40 degrees. It's a reference of 50 degrees. But since 50 and 40 are complementary angles, I can then put my little mark in the top, or I should say the bottom little angle there. And that's my 40 degrees, which would tell me then that this should be a negative A as my adjacent, a negative B as my opposite, and a C as my hypotenuse. So now that we have all of our triangles labeled, all that's left to do is work through the computations to see if these two expressions are indeed equal to each other. Let's start with the sine of 40. The sine of 40 comes from the first triangle, so that's going to be A over C. The cosecant of 140 is going to be C over A. That looks okay. And then let's try to figure out this stuff over here. The tangent of 230 is going to be B over A, or negative B over negative A. I'm going to write it this way, and I'll cancel those negatives in just a moment. And the cosine of 140 is going to be negative B over C. So we do see that our LCD on the left side is indeed what we have on the right side. So I'll simplify the right side first. I'll put an AC in the bottom, and the 3 negatives all cancel to make a negative B squared. And then on the left side, I need to find an LCD, which would be AC as well. And then in the numerator, by working this out, I would end up with A squared minus C squared. All right, well, I do know this in my my triangles. It appears that A squared plus B squared equals C squared. So I guess if I brought the if I swapped these two, I would end up with A squared minus C squared equals negative B squared. So this numerator then can be replaced with the negative B squared that we see on the left there. And indeed, these are the same value. Okay, so this would be a true statement. All right, we've just verified that these, without using a calculator, we verified that these two expressions are indeed the same. So once again, you notice that it involves the Pythagorean theorem, it involves a substitution, a little bit of algebra, and at the same time, it's kind of fun to work this out with the triangles, and we've done a lot of work with the triangles. Hope you enjoyed this little presentation, and I hope it helps you down the road.